if you want to drive Formula One, it's not just enough to have one guy who's able to drive a car. You need to have the right car. You have the team in the background. You need some R&D guys who develop the cars for the next year and all that stuff. So you need a lot. The whole team is important.
Welcome to a brand new episode of our podcast, Human and AI, Mind Machines and the Gradient Descent.
Thanks for tuning in to our geeky podcast to discuss the fascinating field of AI and machine learning, corporate craziness, passion for technology, and the role of humans. We are Ulli and Arberie, your hosts for this episode. And today, we're diving into the world of data strategy and data products in the age of AI. And let me tell you, data strategies form the foundation on which AI can thrive and reach its full potential.
For sure, it's crucial to lay that foundation since harnessing AI can have a massive impact. Let's give you an example of a study of McKinsey I recently came across. It highlighted how companies leveraging AI in the manufacturing process and could experience this productivity gains of 20%. That sounds pretty random, right? But actually pretty impactful. Obviously, in the age of AI, data lays the foundation and brings us the streets, wobbly streets, sometimes very under construction streets, onto the digitalization area.
That's remarkable, Ulli. And do you know what's interesting? Despite all these advancements, there's still a gap when it comes to effectively implementing AI strategies, especially on the shop floor.
Absolutely. It's one thing to have AI algorithms running smoothly in a controlled environment, but it's a whole different ballgame when you're dealing with the complexity of real-world manufacturing.
Exactly, and that's where our genius mind, Erik Schwulera, comes in. He's the principal key expert for lean digital excellence at Siemens, leading the charge in crafting data strategies for DI. With an impressive track record spanning decades in the field of AI, he has the know-how to ensure that AI performs not only in controlled sandbox environments, but also on the rough shop floor. Holding the prestigious Six Sigma Master Black Belt certification, he brings deep expertise in agile process optimization and operational excellence to the table. Join us as we explore the intricate interplay between human ingenuity and AI-driven transformation with our genius mind, Erik.
Thanks, Arberie. Thanks, Ulli, for having me.
Here we go. Welcome to the show.
Please, yeah.
And Erik, there's a burning question that we have, and I guess we should just start right off with it. So can you elaborate on how Siemens is actually transitioning towards building industrial-grade AI solutions?
Yeah, of course, within our factories. So we're coming from a lean factory and now really going into the lean digital factory. Also, Ulli, what you mentioned, 20% productivity, efficiency gain as part of our roadmap. So we have to deliver 7% per year productivity. And of course, we do it with lean tools. However, lean is not just good enough anymore. We're also providing now digital solutions. And we're using really AI use cases, AI applications to really transform our factories, to really bring it into production, into a closed loop systematic.
All right. So that means a 7% efficiency gain on an annual level.
Exactly.
Using data, technology such as AI and these kinds of applications.
Exactly. So really looking at a lean perspective, one thing is really you can try to avoid waste, something the customer is not willing to pay for, or you can automate it if you cannot eliminate it. And now, especially with AI, we're able to automate or eliminate topics we did in the past just by using more smarter algorithms, more smarter approaches also, really game-changing approaches. And yeah, Arberie, as you mentioned, not in the sandbox is everything easy. In the controlled environment, with industrial grade, especially with the changes we have, constant changes we have in the industry operations environment. You need to understand robustness of your applications. You need to identify the risk of applying AI in a productive environment. And that's something we did in the past. And let's say we did successfully. You can really go into our factories and see AI at work.
All right. So there are two sides in the aspects, I guess. What's very interesting. The one side is the data foundation, let's say the data strategy, and the other one's maybe, awesome applications, AI applications,
Yep.
where a lot of, let's say the peers and also other partners still struggling in unleashing the AI, opportunity, let's say, in the manufacturing. So if we talk in first place a bit of a data strategy, right? What, from your perspective, and maybe you give us two sentences of your context. You seem to be around for quite some while,
Yep.
right, Erik? So how comes that you have passion for data strategy? And second, what differentiates, from your perspective, a good data strategy from a great one?
Yeah. Yeah, okay, maybe starting with some buzzword bingo. Everybody's talking about IT, OT convergence, and I have a background as well from the IT perspective, because I also did some software development, heading software development in a company, being product manager for process information systems, so a strong IT background, and also have an OT background from my Six Sigma projects I did more than 300, 500 projects within the industrial environment. So really understanding the factory processes and really having IT and OT, not only some knowledge, but deep knowledge here. So I see how to create value for an OT perspective in the factories and what's necessary to have an IT operations also up and running. So really coming from both areas, IT, OT. So I'm the living IT, OT convergence.
Here we go.
Guy.
Here we are.
It exists.
And that's part of the knowledge. Okay, we need to go into machine learning operations. It's not just a one-shot learning. We need to make sure that we're able to really retrain the models. So we need to operate with data pipelines. And we also know that data is, especially in the industrial environment, never perfect. So somehow you need to have a strategy how to connect the data and also how to use the data. And very important point, in the beginning we thought it's enough to have a connectivity strategy and an AI strategy. So how your data sources are connected somewhere and how your use cases generate value. But now we also learned the missing piece in between is a data strategy. How you manage the data life cycle. And that's an important point. It's not just data, which is available. It's also, you have a life cycle and you have a data owner in here. And that's also what we learned is very important to differentiate between just having a data strategy and cutting edge data strategy. We really did the operations concept on our data strategy to have really data pipelines robust running. Not everything, but we learned also how to make them more robust and how to really provide data for the data consumers, for the people who really create value out of the data. What is needed to give them the data they need to really do the magic of the data.
So is there kind of a layer model which you're following up on a data strategy? So that means, okay, you said at the very down, obviously connectivity is one of the bases. What strategic assets or assets of strategic importance are being actually connected with what kind of standardization, I guess. Then you said you have the top layer, I guess, business and use cases motivate the value. And then there's in between. Can you a bit of more depict what the fundamental core pillars in this is?
So we're striving for a data ecosystem. It's also we have implemented a use case agnostic data ecosystem where we have data producers and data consumers. So there's one important point here to understand. Okay, it's not just you only have data consumers and they have to take care of everything. It's really so we produce data in our factories. By when you look at the machines, you have your product, you have your material coming in, and we track everything in our factory. We do some testing, so we see also the behavior of the product. So we have material data, we have product data, we know the process information regarding the process, we know the status of our machines. and the data measure of everything together, of course, creates the value. But for each of the single pieces, you have a responsible data owner, and he's sitting not in IT, he's coming from OT. These are the domain experts who exactly know what is important to run a factory successfully.
Okay, is that the best practice? So data ownership shall be with OT? Don't get it wrong, IT. You're awesome, right? We need you, IT OT conversion. But
from my point of view, you need to have the understanding of which is the most important point of your data, the data points, also the frequency, how frequent you need to upload the data, and also we call it semantic modeling. Of course, sometimes just physics behind that one to really understand what is necessary to identify the output of your process. Like you want to have good. We are producing printed circuit boards here in our electronic factory. Also, you want to have perfect soldering of the printed circuit boards. You need to understand which are the right process parameters. How do we place the components? What are all the necessary measurements to really make sure that we have the right quality? So that's the domain experts can tell us which is important. No from IT can really tell us, okay, you need to look at the volume of the solder paste you printed, or is it more the shape, or is it more the offset we need to control? That's part of the domain knowledge you need. And also you need to identify somebody who said, okay, in my data set, this and this is an important column. And that's why we need to send this column or to provide these columns to our data consumers, like process experts, like quality experts. And that's the key behind that one. Not just having somehow connected the machine, sending some files to the cloud. And if the file is correctly sent to the cloud, then that's my topic is done. That's the key difference. Of course, you need some IT support here to make the pipeline up and running, stable data pipelines. However, which piece of the data is important and how often do you need to measure the data or send the data to your ecosystem. That's something also which is very decisive here in building comprehensive AI systems, which really provides value.
And if you would maybe summarize that, so we have like different roles, we have data consumers, we have data owners, we have that IT-OT collaboration, but what would you say are the key ingredients for a really good data strategy that you can like provide the audience with?
Of course, the data owner is one key player here because he's responsible for really providing the data set, send it to the data ecosystem, put it that way. Could be edge, could be cloud, whatever you like or whatever your requirements are from your industry. That's one key player mentioned. Of course, you need to understand your data consumers, the needs of the data consumers. What are they doing? Why are they needing the data? So user journeys, persona comes into play. You need to understand what are their jobs to be done, and especially which frequency do they need the data, what about the latency. Can you wait one day until the data is uploaded, or does it has to be near real time? And in the middle, I wouldn't put it as this data steward. I really would say it is the chief data officer.
Do we need a chief data officer? Does a corporation need a chief data officer?
From my point of view, yes, because he's responsible for the...
Maybe it's a she even, right? Hopefully.
C-level, yeah. If you look at the most important thing is the task, not the title. And he's responsible for orchestrating all the different demands, orchestrating the tools and the ecosystem. So he's shaping the ecosystem. And it's also, from my point of view, very important to not to think about a data platform itself. It's an ecosystem with partners, and fully orchestrated and also global. Should be global. If you think of a global operating company, should be somehow global available. You need to have an exchange, best practice sharing between the different sites. And that's also, from my point of view, the most important key success factor. Somebody who's orchestrating the whole shit.
That brings a lot of, I guess, obviously living now in a large organization is a bit different animal, let's say, as working in a smaller organization, because that stretches quite some competences which are needed, bridging the world between domain know-how, process know-how, use case know-how, data expertise, right? Data science expertise, maybe even AI expertise. How do you see that? Or what are kinds of different persona skills? Are embedded. It's not easy, even maybe also for Siemens, not to to embrace on that kind of level. What kind of trainings are needed? What kind of skills to adopt?
Of course, if you look at the use cases. How to build use cases, doesn't matter if you look at the MLOps process or just the cross-reference industry standard process for data mining. It starts with business understanding and data understanding. So if you have a good data scientist with business understanding, he can also start building powerful use cases. In many cases, if you don't have the data science know-how in your company, you bring data scientist, an external data scientist in, you have to really make sure that he's talking to business guys, and the business understanding and the data understanding comes together. So you need somehow at least to train your internal domain experts in the language of a data scientist, that he's able to talk to data scientists, understands the different terminology, the words, what he's using to really fully understand what information does data scientists need from my point of view to build these powerful use cases. And we had also some anecdotes from one use cases where the first one we tried to implement on the shop floor, and we tried to convince the quality expert that we're doing nothing stupid with this approach we're doing. And in the beginning, just ask us, okay, two questions. What is a data science? What is an AI model doing? I have no clue. It's a black box for me. And also what a data scientist is doing is a total black box to me. He's just sitting for his computer, do some magic, and I just should trust him. Please convince me that you're not doing anything stupid just by using data for anything, but you don't understand my problem, my use case. And then, hey, good point. We never talked about what the AI is doing and also what a data scientist is doing. And we really had a good conversation with him. And we also talked to him like, okay, you're doing a new product introduction. Are you doing a new technology introduction in your production? And these are the steps you are doing. You do some verification, you do some testing, and you are taking care of the risk of this new technology you're bringing to the shop floor. And the same things we did, same steps we did with AI, and the same steps we did with the data. We do validation on the data. That is, the performance is doing exactly what we see on the shop floor. And that's how we validate the system. Oh, interesting. Okay. If I compare it to new product introduction, new technology introduction, I also have no perfect proof it will work forever. So we also have the mechanism in place on the shop floor to discuss the deviations which are occurring. And by that, his mind may click. So just a lot of triggering or change of mindset. He said, okay, cool. So we can use this new technology also in our shop floor. Great thing. I like to do it because it's innovative. We want to be front runner on that topic. And I see it's not a black box anymore. You guys know what you're doing. You guys just showed me that you understand my process, my challenges I have, my jobs I need to do. And so that was one of the biggest barriers we just solved by doing a very interesting talk about how we apply AI in the factories. So really we have to make sure that you tell the people what you're doing, not just great technology, just trust me.
So there's quite some challenges in implementing machine learning and AI applications in the manufacturing or the OT space, and I was wondering how do you cope with the challenge of non-scale, right? So when we engage with partners and so on, then we say like, and it's a very specific use case to be solved, right? We're not about building a recommendation system for 1 billion people, right? We are tackling real world, hardened industrial grade stuff, right? Which maybe happens only once in a factory, twice in a line, 3 times across, I don't know, the location, stuff like that. So on the one side, what is the bit of the best practice, how to cope with this single pony AI magic, let's say, right? And the other says, how do you convince your management to invest in that? Because the business, needs to be quite right. And this goes along, from horizontal perspective, who funds the data strategy, right? Let's say the data layer, and who funds the business application. Can you share a bit of, how we tackling this complexity?
Yeah, we're coming from a top-down approach. So we just in the beginning, Lean Digital Factory, were transforming our factory, and the big data analytics part of it's my responsibility. And the question from the beginning was also, what's the benefit of your whole approach you're doing? So bringing data to the cloud, nice, but where's the value add of doing that? We can do better tracking and tracing. Nice, just nice. Getting better insights, so but that's not the value, because I can go down to the shop floor, I see what is produced there. I don't need to have it on my smartphone. It's not additional value for me as a plant manager. And also my people there already know how, maybe in a silo, not connected, not fully connected, but the transformation is the value add. So look at the data analytics and AI. What is the value add you bring in? And again, coming from the lean perspective, we identified reduced test effort, because testing is not adding value from a customer perspective. It's a business need we do. So why not reduce test effort by reducing the retesting unnecessary, or you can do sample testing instead of 100% testing. So that was one chunk we address with AI. Also, in the past, we were not successful because of blah, blah, blah. Now we have AI. We can tackle this field of potential. The next field of potential was the unplanned downtime of the machine. Let's say predictive maintenance was a topic. So, okay, we also can use AI to tackle predictive maintenance, and we know the downtime of our machines. We can calculate the benefit. And we could say, okay, 25% of this chunk we're going to realize within the next 3 years using AI. And the last topic was autonomous decision-making, closed loop, using AI, also with a chunk of money. And so we already know the business potential we're addressing. And of course, still a global approach, I know. And of course, then you pick up problems where that the problem is scaling. So every electronic factory has trouble with false calls in the production area. False calls per production line. And if you look at the whole SMT production line, surface mount technology, where we produce the printed circuit board, we have roughly 50 SMT lines within the DI factories. So we know already that the problem is 50 times occurring. And of course, we have this variant, different product variants. That's also part of the single pony challenge. And that's something we started with the high runners. So we know delivering value, one piece of the value, we're delivering the most piece of the value by just bringing the false calls down for one of the high runners, increase the first pass yield of the production line, the output of the production line. We can calculate that one. And that's how we started with the approach. So really looking at the biggest piece where we can do the transformation. Not the easiest one, but the biggest one was the challenge here. And we really made a conscious decision not to pick up the easiest one.
But that's a different So I hear that you say like, okay, yeah, you look for scale. So you look for the biggest pains in your manufacturing. So look for the biggest scales. Okay, then calculate a business, right? A business case because it needs to be profitable. Maybe it doesn't cover the invest, right?
Yep.
And but still have it and look for scale outside the factory, or across the lines and outside the factory. What do you say? Though then even if you have this somehow similar process, let's say testings, let's say our downtime, for sure, everyone has somehow, though it's different machines, different animals, different data, different models, right? So is the aspiration then, test and learn on the current lead factory where you explore that and then shape some kinds of reusable assets that are more easily to be adopted to the new line? Is that the approach? Or do you think, it's like a software, okay, we developed it once and then we need to, it almost need to have the 99% go in, right?
So this is also part of the learning journey we did. And also coming also from my background as an electrical engineer, so there should be not only data relation, so not only a correlation, there's a cause and effect pattern behind that one. And we're talking about physics, we're talking about chemical processes we have, and so the physics is identical across the world, at least what we know today. That the physics still in China is the same as in Europe. And that's also the mindset behind that one. So we're not looking at what format is coming from the machine. We're looking at the causing effect. So the logical input into that one. And we try to map the physical input to the logical input. It's also part of the data strategy to have really a logical model behind that one. Not just you look at the table and said, okay, table 1, 2, and 7 is important as feature. No, it's the logic, the semantics, the physics behind that one, which is important. And we trying also to validate that the correlation we see or the input-output behavior of the model is based on some physics that really makes sense what we are doing when we go into the closed-loop control. That we're not reacting on any noise in the production area, that we really make sure that we understand the process, we understand the problems, environment, and that the approach is really scaling. So let's say we identified for having these false calls, the real errors on the PCB production, the volume of the printed solder paste is very important. And not only the volume for one component, but the difference min-max of the component. So also there's a relation between these two or more, depending on the component we're looking at. And that's the key feature for the model. So the key root cause when we have problems. And that's something we need to understand. And that we identified, and we can now have a pre-calculation for all factories, for all production lines within the factories. Please have a look at this behavior. Do you see any change or a critical indicator where we need to adjust the process? And again, so it's the learning, not only how to train the model, but also what are the influencing factors in detail, and we are sure that this behavior is scaling, not just only the connected machine with a parameters, with a strange format or with a unique format. It's really understanding the problem and make sure that hopefully the machine is providing this parameter. And now in addition, what we also did, next development step, not in the beginning, but now with federated learning, we can even have more variation in the input data. And also found a solution that maybe if one factory, one production line is not able to provide the data, that the model is also able to run with less parameters. So it's also something we learned towards the more generalization of our models, that the scaling is more effective. But it's total cost of ownership approach in addition on top of that to somehow get it up and running.
What you described also earlier was that there's a big ecosystem and there are a lot of different stakeholders and different players, and it's like a very quickly changing environment. And how do you actually manage feedback there? So you come up with a strategy, with a data strategy, you put it out there, and then maybe you get feedback from one of the data owners that something is not working. How do you deal with that, especially in such a decentralized setup?
Yeah, also coming back to the IT-OT convergence. So we made sure that we have an IT service partner. So we really have the OT guy is the application owner, IT guy is the service owner, and that we have also a federated service concept for that one. So we are not blaming the IT guy. He's not able to deliver something. That was also very important for us to really have this IT-OT couple to scale it. And then if you have any feedback, you can say, okay, is it something we change on the OT side? Is it something we change on the IT side? And then really learn together and do the changes in the data strategy, made some fine-tuning with the roles and responsibilities in detail of who's doing what. So in the beginning, maybe we said, okay, it should be done by OT. Then we learned maybe it's not clever because the OT guy is not changing any firewall settings. So there should be somebody in between who makes sure that the firewalls are still well defined and nobody's doing anything stupid with the firewalls. Happens sometime in other factories. So really, it's again, we are on a learning journey, and also was very important here that also my manufacturing had also said, okay, it's a learning journey, and please do not only come up with success stories, please also come up with areas where you have challenges, and what challenges do we need to tackle, and because when we see these challenges internally, our customers will also have the same challenges. So please speak openly, speak frankly about the challenges we have.
Let's talk about the challenges. What are the challenges? Come on, you have
Let's
1,
speak
2, 3.
openly about them.
1, 2, 3, which the usual suspects maybe, right?
That was really about the data integration. So everybody's talking about data connectivity. Just find the right plug to your machine and bring everything to the cloud. No, that was the easiest thing. Just send data to the cloud. It's really about the also the extract, transform, load topic. You need some software to do ETL processes. Yes, you can find it. Also, no, not challenge. But in which data format are you transforming it? Is it the one world global data format for industrial production? And also, we found out no, it's not that easy because it's we talk about process data, we talk about product data, we talk about machine status data. So the classical IoT stuff with time series, that's not working for product or process information or for material information. So how to bring all these together? Data integration is the biggest challenge here. And also get the data pipelines stable, up and running. We have different responsibilities in the infrastructure, and really to make sure that everyone is aligned. And also in the past, if you have a POC, it doesn't matter if data set is not coming to your data ecosystem. But if you have an operational use case and the data is not up and running, and you don't have the IT service, incident management, problem management behind us to fix the issue quickly, then you're usually running blind. Your application's not running. And the IT guy, well, I think it was a POC. Why is it important? Production is running. No, but our data production is not running. We never have been informed that you have a data production. not my business anymore. Oops. Then we also found out, okay, we need to make sure that the role understanding, so it's really a data production, and we need also to make sure that our service level agreements are coping with that.
So you're running two factories, the real factory and the data factory, is that? Huh?
Yep.
Okay,
as Roda Bush said, we have a digital twin of our factory with the data factory and the real factory, and we just have to combine it. And it's also one learning we had. It's really the same complexity. You need also people who understand running a digital factory. You need here is both again IT OT. You need to really maintain it, and maintenance effort. You have to calculate it. And really, it's not just a product you do or a project you do with AI. It's really you do AI operations later on. And it's something you have to calculate. You need to have a budget for it, and you have people to run it. Sometimes automatically, but still you need the people.
So here's a tricky question with regard to funding again, right? So you have a data layer or a data mesh, data strategy somehow, which is fueled into some IT infrastructure, which has a cost. And then you have specific use cases, and which also have a different cost, also life cycle cost. From your experience, who should fund what?
Very interesting discussion because also if you look at the budget release process, also for within Siemens, what we're doing, it's still use case driven.
Okay.
And you need some guy, and I found with the MCIT head, when we talked about, look, we need to run this DevOps service. We need to make sure that the people stay on board. And he understood it, that we have to think about a DevOps concept for the platform, not use case driven. And so we have a DevOps budget, part of it for development, new cases, part for operations. And we just did a pitch in that direction that we needed to keep the people on board, to have an efficient and effective operations. Because you have people, you already know what they've developed and they stay on board. And he said, okay, it's the right way to do so. I give you, we plan the budget on a DevOps piece and not on a use case piece. Of course, for each use case we're onboarding on that platform, we need to make sure that the cost-benefit ratio is given. However, we are not calculating it for each use case as a silo. It's really, we have the ecosystem, so we have the platform cost with DevOps covered, and we have just the onboarding of the use case and the operations of the piece of the use case. And so we really do the separation of that one. And that's also very important, because we know already that the first use case, if you have to build up the ecosystem, the infrastructure, it won't pay off. So in the early beginning, you have to be aware if you start that journey towards data-driven company, data ecosystem, however you call it, that the first use cases will have a higher invest than the following use cases. And that's something, if you want to go into this direction, if you want to drive Formula One, it's not just enough to have one guy who's able to drive a car. You need to have the right car. You need the team in the background. You need some R&D guys who develop the cars for the next year and all that stuff. So you need a lot. The whole team is important, not just one idea, one crazy guy who's.
It's a nice pardon, right? Comparing the data strategy with launching a Formula One team on Monte Carlo, right? Yeah. Or maybe.
That's a beautiful metaphor. And moving away from Formula One to something that is as high in speed, I guess, right now are the data products. It's like there's quite some buzz around it. Can you maybe lead us a little bit through the specifics? So what are data products actually about? Is it just an application, or why is it even important right now? And what should we do? What should we know about it?
Yeah, so of course it's a hype, it's a buzzword, data product. Everybody's talking about we need data products right now, and everybody's jumping on on that horse or on the train. But
Or in the car.
yeah, or on the car. Just the example we talked about earlier regarding the I want to reduce the false calls of my production line, and we identified. Of course, we were measuring today for each board, for each component, the amount of solder paste we print for the, we call it pad, it's the, let's say how the component is connected to the board, with at least 2 connectors of the component to the board. And we just measured in the beginning raw data for each pad, for each connector, the, let's say, 8 parameters. It's the raw data. Then we identified, okay, the volume is a good indicator, and the difference between the both connectors of the component is very important. That's something you can calculate. And the calculation and the provisioning of, okay, we want to do this calculation for each board, and we want to give this information also to the process experts, or it's an important information for the algorithm to do the closed loop control. Then all the information we need, the board number, we need the timestamp, we need that information regarding what is the range of the solder paste we printed. Then you can see, okay, you need to put together these 3 information, and that's the data product. And you're delivering to, or you're providing to anyone who's interested in consuming this product. So coming really from raw data, a lot of raw data, then do some combination of the data, and then provide it for everyone constantly. So it's part of the data.
But is it an API, or is it a visual dashboard? You know, would you differentiate, or is it like, you know, it can be everything as long as you have this data prosumer and consumer aspect.
Right? So it's really a piece of data you can retrieve from the data ecosystem. Doesn't matter if it's part of a database or is it
mesh or
a data mesh approach. So something you can provide, and it's you also make sure that it's constantly produced and available for each product you're producing, and also stored on a persistent way. So it's really data with a special combination with a data model, and also an ownership behind that one. And also very interesting here, you have a data lifecycle, like you have a product lifecycle management. You start to have, starting with a data lifecycle management. From the first exploration phase, where you don't know exactly what is the combination you need to provide, until, okay, you found your combination, then you want to provide it as a 1.0 or 1.0, yep. So it's the first version of your data product. And if you need additional information, let's say, please, the offset is also very important of that solder paste. You can add this information. You have your product version, let's say 1.1 or 2.0. And if you find out later on, okay, you have a new algorithm, you found something better, this data product is not needed any longer. Then you have also the end of the data product. You just shut it off and don't produce this data product anymore to save cost. And of course, you have also the responsibility of the data owner about the storage, the archiving. How long do you keep this data product in a hot storage area where it costs a lot of money? Or can you just put it to the more cheaper areas of the cloud computing or edge computing area?
And so the biggest advantages of data products from your perspective, in short?
So from a data consumer perspective, I know what I get.
Yeah.
And I have the guarantee it's provided the way when I need it, in the form I need it, the right time, right format. It creates value. You can put a value tag on that one, and you have a managed life cycle. And especially the life cycle is very important. Not just naming anything as a before it was just a database, now it's a data product, call it. Now it's the life cycle behind that one, which is making the difference.
Continuous updates, validity, cleans, and high frequency, real time.
And especially, you need to make sure that you create value with your data product. And if nobody wants to pay for it, because the value is not given anymore, then you should also say, okay, if it's not providing any value, I switch it off.
Industrial data products, say that. So if we skim one level a bit of, as we come and emerge into the end of, unfortunately, already today. So if you skim out, so back in the days, there has been always, with regard to the maturity of let's say, manufacturing area of factories or corporate overall, we differentiate between 4 levels, sometimes 3, sometimes 4, right? What is going on, what has happened, what will happen, and maybe, how to prevent it anyway, preventive maintenance aspects, right? And in the current times, I think you also resonated about somehow swapped. It's not always like this 1, 2, 3, and you can't jump over that. Usually, obviously, we say, but I have the feeling we are moving different pillars sometimes. So the one thing is, learning from the past. The other is currently we learn from interaction, maybe also from the process engineer or from the tools. And the other aspect, can we go rather closed loop? And you mentioned a couple of them closed loop. What is your recommendation? Is it still go 1, 2, 3, don't jump over it? Or what's the caveats jumping for first place and then leave it out the ones?
No, it's really, there are no shortcuts from my point of view. So really coming from 1 to 4 will not work in most cases, I think, because the risk is either too high that you do something stupid, and maybe also the people who are working with that information are not trustworthy, not explainable enough for them. So I think the high risk that they don't really accept this new solution. And especially with the predictive stuff, if the AI system is telling you you should change the motor of your car, would you really do it? Costs 10,000 euro. Just because an AI system is telling you the motor will break down next time you drive it to Munich. I would just say, okay, I don't trust the information. Never happened before. I just give it a try. So also the acceptance of the results will not resonate in the people. So you need to use these steps to gain trust in the system. That the organization will adopt the new solutions, and maybe you can shorten the time from 1 to 4. And you should also have, during the strategy, it should be clear that you want to achieve 4 in this area, to really prepare for the right steps and for the right timing of the steps. And also what we see here, we have 1, 2, 3, 4, these approaches at the same time, depending on the area of the production of the product. We need some new insights. We got a new supplier, or we've seen some problems with one supplier. Then you start back with the analytic stuff. So really descriptive analytics, what's happening here, what is or really understanding what is the real root cause behind that one. So you really start with 1 again, with the descriptive stuff, to make sure that maybe within 6 months, 12 months, 24 months, you're able to predict something out of it. And all these things are more or less in parallel, especially for maintenance. So predictive maintenance is not the magic key. You have to balance scheduled maintenance, condition-based maintenance, and predictive maintenance. And again, orchestration, it's also depending on your current situation. So predictive maintenance is just a very high potential you can bring in. It's a tool you can use, but you have to balance it to your needs. And also regarding Gen AI, we see also this nice picture here about Industrial Copilot. Also interesting observation from my point of view. So the past, let's say, until 2 years ago, we trained machines to talk to people. now we train people to better talk to Gen AI. Also, we accept that we have with Gen AI a powerful tool. We have to make sure that we are doing the right prompts and identify hallucination with what the AI is doing and really feeding only back what makes sense from our point of view. So really a paradigm shift again, not training AI models, but really here fine-tuning and make sure that we do the right inputs, get the right outputs when we feed it back to our industrial context.
Training the humans, not the machine. So, Erik, you put it in a very beautiful way, and you brought up the human, and this is also a human and AI podcast. So, how do you actually foster that culture of innovation and adaptability? And you're in a highly innovative space, and earlier you also mentioned like the failure culture that is also highly encouraged, and now also like people need to like be trained and get more familiar also with, for instance, Gen AI, but. Yeah, so what you say, how can we really foster that culture of innovation in these times?
Also interesting, so ChatGPT, they come with a playground also. And also what we did within Siemens, we also had this Gen AI playground, OpenAI playground. You can also just start with using the tools, just get familiar that you have any barriers with the new technology. That's something encourage the people to play with the new technology. And of course, coming both generate interest in these new technologies, and also you have to identify, okay, how can we use this new technology to transform again some of the processes we have, do some automation in the engineering area, do some automation in the maintenance area. So really bringing both worlds together. However, for the people, it's important that they are willing to use this new technology, willing to use these new tools, and they are empowered and enabled to really understand what's behind the scene, what's under the hood of such a tool, again, AI, because it's nothing perfect. It's still mathematical machines, fascinating, but still it's a computer and it's not perfect. And so understanding both opportunities you have, limitations, that's one of the key things. And best thing is really just try it out, gain your first experience and learn from this experience. That's the closed loop again. But for the human people, for how do I learn to use this new tool? What are the limitations? And maybe also think about if I see some limitations, how can I get beyond these limitations? And that's part of the innovation again.
So AI literacy is key. And I guess you're also strongly contributing to us and the audience learning more and more about this very exciting topic. So maybe if you look ahead into the future, what are some like trends or technologies that you currently see that might be also interesting for Siemens or for Siemens to integrate in our data or AI strategy?
Generative AI is surely the hottest topic right now. Foundation models also, Ulli, what you mentioned before, becoming the one pony dilemma, that it's really scaling better. We can reduce the cost. And it's still, if you look at the whole machine learning operations cycle, it's still very expensive. So you just can tackle also only use cases which are providing enough benefit. So that's something also I see that the upcoming technologies, innovation steps, lowering the costs for the operations. And also what's fascinating, ChatGPT vision, so that AI system is able to really understand the context. And maybe it's also how to use this new technologies maybe in identifying scratches, failures in the production environment. It's also something very interesting because you don't need to train the AI on your products because it's already able to identify scratches or missing pieces just by looking at it. And again, it's more how do you integrate these new technologies in your area. And that's, I think, the most interesting things not to come. And also, again, paradigm shift, understanding how you can use the the technology, not training it, but really using it.
I stumbled over an interview from OpenAI, which is quite interesting. They say at the moment, GPT technologies are primarily used either for accessing index knowledge, like say a humongous database, and or generate syntactic data for enhancing our copilots or interaction. Yep. And he said this is actually not the right approach for in the long term from their perspective, because they say that we have this hallucination, we have this bit of unreliability in certain kinds of aspects which you can mitigate, but it's not, if you use it as a database, it's maybe not the right perspective. In the long term, you want to use it as a problem solver. So it provides you solutions to things that you have not thought of. And it's an interesting aspect which they brings into RaceNet, not just only say it's a Q&A bot, right? Mm. And here are the rules, and please behave. We're using RAG for training, augmented retrieval aspects, techniques for doing that, but it should come up and provide you to challenges which are super tricky, and which somehow it gets the background information to have actually providing solutions. And that's an interesting statement from the mothership, let's say. Is it?
Yeah, also interesting. Understanding the technology behind that one, it's a large language model. So if you can describe the problem with language, of course, it's able to come up with a solution based on language. And I think also it's fascinating technology. And don't get me wrong, it's really very important technology, because the whole communication is based on language. Also, the business modeling we're doing is based on a language. So ChatGPT in general, or large language model, could be able to create business processes for us, come with new solutions for business processes. However, by definition, they are not able to understand physics. And though the physics-informed neural networks still these type of neural networks are getting also very important, especially for the industrial applications, because it's most of the industrial applications are based on physics, on chemics, also really cause and effect relations, and by definition, the transformer architecture is not able to understand real cause and effect relations. It's just you have the attention layer. There's some correlation between that one statistically, so there could be something, but it's not based on really cause and effect analysis. And that's something very important, I think, for the future, to have really the combination of both worlds.
Reminds me on Elon's quote, "Physics is the law and everything else is recommendation." So we come in a bit to the end of the podcast, but obviously you have remarkable experiences and the positive thing, and I think I would love to talk for the next 10 hours with you, Erik, believe me, because I found it very tempting and fascinating, from leveraging and learning from your experience. And so maybe also outside the folks here, and given your experiences, what kind of 1, 2, 3 advices would you give to folks out there who are enthusiastic, love AI, love data, maybe consider maybe joining Siemens or not, but being passionate about technology? Are there 1, 2, 3 things you would share with them?
Really be curious. That's very important. And also really understanding the limitations and work on the limitations. Especially when I started 30 years ago working with AI, first thing I was really trying to model something, and the results were catastrophic. So it was not even close to what I was trying to achieve. And so still was, okay, the approach I did was not correct. I tried to solve a dynamic problem with a static model. So really understanding your business and the approach you're doing, that's also something. Really understand the basic behavior of the AI is also very critical, and also understanding your basic processes. So again, business domain knowledge is important, not only data science domain. and also really look what the partners are doing on that stuff. So it's not Siemens alone who can solve any problem, or Microsoft or AWS can solve the problem. It's really the open ecosystem, the partnership, that you have the openness to talk to other people who have also clever solutions, clever approaches, talk to them, and really bringing all the partners together to solve the most important problems we have here. Not only for the industry, but also for environment, for society. And that's also the open ecosystem. Openness is also very important. Open source, and also very important that maybe also the democratization of these models, not only running in data centers, but also maybe on a computer or on a smartphone. What the LMU is doing in Munich right now with Stable Diffusion, one example. Also, I really strive to get this generative AI running on everybody's PC, that everybody's able to use this technology. Not only do you have to pay the hyperscalers enough money that they do it for you. It's also very important here.
That's good advice for sure. So we'll be curious, and you can be also curious for the next episodes coming up. But before we close off this one, we want to thank you for your time, for the passion and the dedication that you shared. And before we finish off, we want to play our favorite game in the world, Authentic Autocomplete.
Even before ChatGPT, right?
Yeah, before ChatGPT. This is how old we are. So now we have the prompts, and you can be ChatGPT and answer them. So Erik GPT, let me give you for the closing a couple of sentence starters, and you'll finish.
Yep.
Erik, are you ready?
Yep.
Final challenge before the weekend. AI is
a fascinating technology, but you have to understand the limitations.
Beautiful. A data strategy is
very important, but make sure that it provides value and not just written on a paper, because then it's just another waste.
So real value is key. Siemens is?
From my point of view, because now within Siemens for the third time, for me it's the right playground to do some innovations and really to leverage my know-how and really create industrial-grade AI solutions together with partners.
All right, I'd sign that. And last but not least, if I could invent one rule for everyone in the world to follow, it would be?
All models are wrong, some are useful. So don't strive for the perfect model, just use the model fit for purpose.
Nice, love that. Erik, thanks so much for spending the time. I know you're busy. I am a most VIP person on data strategy in Siemens, I believe, right? And thanks for being such a passionate mind, right? And folks out there, startups, right? Stay bold and committed and open-minded, curious, as Erik said. Thanks for tuning in. Connect with Erik on LinkedIn. And we see us and hear us at the next Siemens AI Lab podcast. Cheers. Thanks, Erik.
Cheers.